Okay, so in this video, I want to talk about our the project, and you have to find this, the project document and then Excel file uh, at the D2L. So you have to go to the D2L, activities, and assignment. Then you will find our project. So you have to open this, Word document, and also you have to download those three Excel files. The due date is July 19th on Sunday, 11:59 p.m. Late submission is possible until July 21st, but there will be appropriate deduction. So to avoid, any deduction, you have to submit this one by July 19th, Sunday. And you have to submit the following two files. One is this Word document with all those answers and then the graph. And then you also have to submit the R file. Now, please remember that one of the purpose for this project is that we have to kind of assess your knowledge in this program, the R. So what you need to do is first open the RStudio and then go to the file. Make sure that you choose the new file, not new project. You choose the new file and R script. So this is where we can actually start doing the project here. So let's say this is a Math 2050, the project. And if you want, you can just type the name here. Now, uh, you can kind of start doing this now, or you can do it later, but eventually you have to save this file here, this space. So go to save as, and then save it to your, the computer. And then you have to submit this R file here, not this one or anything else, just this one. Okay. So the first thing you have to do is, you have to download two files. One is Braves. The second one is Falcons. Now those are the project data, so I'm not going to really do that here. Instead, I will download some kind of a sample data. So it's a different data set. But for the project, you have to, let me just show you here. You have to download like something like this. This is the Braves, and also you have to download this one, the Falcons. Now later, I believe it's a part two, you have to download another one. I believe it is this. Atlanta Braves. It's a kind of a little bit different data set. So for this particular demonstration, I'm going to download actually the Detroit Tigers, this data set. So I'm going to download this one. And also I'm going to download Detroit Lions. So let's look at the following. Go to the RStudio again. Import data set. Now, if you know how to download this like a kind of on your own, please do that. But this is kind of a very convenient. Choose the from Excel and then browse. So I'm going to download, these two. First, I'm going to do the Tigers here. Now, depending on, actually in this case, you can see the preview. Sometimes, this preview may not be available. So we're going to just import here. So this is the one of the data set. And I'm going to download the second one, which is Lions. I have them in the same location. Again, sometimes, depending on the version of your R Studio, this preview may not be available, but that's okay. Just, import this. Now then, this is what we're going to do. Here's a kind of a part one. I'm not going to go through everything because, you can find like each tutorial in the previous, like, those are lecture note or like those video. So you can check those tutorials. I will just kind of do one demonstration. We will find mean value of the Braves. Now, for this demo, it's going to be the Tigers. Okay. So mean value function is just simply mean. And I have to bring up our data, the Tigers, and we have to choose the appropriate column. That's the weight. And this is it. This is how you can get the mean value, which is a 206.5714. Now you may round it to like a 206.57. You can type the number, or you can just simply copy this one. And then, go to our project. And here's our kind of, the question here. So I can just simply copy and paste the solution. So you do have to provide, a solution like this, and you have to do, everything, mean weight for the Falcons, standard deviation for each team. I'm not going to do all of them here. I will show you this a box plot for each one. It's not individually, but side by side. And this is what I meant by the side by side here. So this is the, box and whisker plot. It's just simply this function here, box plot function. But we have to compare these two teams, kind of the same variable, but this is a two different teams. So the second one is the Lions here. Now, this is it. If you do it this way, so I'm going to run this one. We have side by side, those are, two box plot. Now, depending on your laptop screen, this one maybe looks a little bit better, or maybe if you want, you can just, change the direction. Horizontally. And then you have to, again, copy and paste. So right click this one and copy image. And then go to our document here. And this is where we're going to do, copy and paste. But I will try this one, paste the special and device independent. Now you can adjust, some size of this one, but this is what you can do. And then part B, you have to discuss what you see in these two box plot, similarity and a difference. So there are some outliers in one of the set. There is no outlier in the second one. And I'm sure we can talk about, many different things. So just that this is some kind of a discussion based on your observation. Okay. Talk about similarity and talk about difference. Now, the next one, this is number 4, is something that I just want to kind of pay kind of extra attention here because technically, this is just simply doing some kind of a probability, kind of going back to the chapter 3, but we are not using any particular, say, R function, because, if you remember, those, normal distribution for those are R or even the calculator. We are not going to do that here. We don't kind of do that kind of a probability distribution. Instead, simply If one of the players is randomly chosen, what's the probability that this person's weight is greater than 220 pounds? That's a part A. Part B is the other team, football team. One player is chosen. What's the probability that this weight is greater than 265? I want to show you this kind of a couple of different ways. Okay, so again, I'm going to use the tigers, and then it's a greater than 220 here. Okay, so first, let me just kind of show you what kind of a data we have. Now, I do not recommend this, but you can see the total, all the data here. You can count how many of them we have, and you can count how many of them are greater than 220. Then you can talk about the probability. But there is a better way to do. You actually take length of this one. So we have 42 here. The total number of data in this team right now is 42. Now you have to count how many of the values are greater than 220. So one way you can do that is just taking this, the sort function, which is a rearrangement. So it's from smallest to the largest, and you can see here, this is how many of them are actually greater than 220. So you can kind of count this one, divided by, the 42, then you get a solution here. If you want to do this a little bit differently, you can try another, as a length function. And then what you can do is, out of this column, we will only select those values are, just a weight is greater than 220. So by doing this one, they will only select the value greater than 220, and the length function will give us how many. That's an 8 here. So the answer is 8 out of 42. So you have to do that for, the other one too. Like, this is part B. You're going to do this with Falcons and then greater than 265. Now, number 5, you have to create a histogram. Now, this is where, you have to choose which one you have to do. If your last digit of a school ID number, that's like a 9-digit number, is a 0 to 4, then you're going to use the Braves. If your last digit is 5 to 9, one of those numbers, you're going to choose the Falcons here. If you want to do a little bit, kind of a better the graphing approach, you can use the ggplot template from the chapter 2, or you can just simply use the, histogram function. I will just kind of do one demonstration. I'm going to just simply use a histogram function here. Again, for the demonstration, I'm using the tigers. And, you don't have to have a really, I guess, many interesting information about this histogram. Just to create one, and whatever you get out of this, that should be good enough. Okay, so again, I want to copy this and paste into, your Word document. Okay, so depending on the last digit of your ID, that's what you are supposed to do. And you do have to copy and paste into this. Part 2, you have to download different, those variable set, and then some, information about those each column. This is kind of, exactly what we did in chapter 12. You are supposed to do the correlation coefficient and regression equation using this specific, those the variable, and you just have to answer this, and then you also have to do this, the graphing problem. Again, you may use a ggplot template, or you can just use this plot with a appline function here. Please check this one in previous document or previous like those lecture videos. You can find like these tutorials. Okay, so please do that, and then also you have to take care of this the particular prediction problem. This is very similar to those some practice problems we have in chapter 12. Part 3. Now, part 3, I'm going to just say that this one requires chi-square goodness of fit test. This is the chapter 11. So if you go to the chapter 11, pick up chi-square goodness of fit test, look at the example with a R, not the calculator. Okay, this is about using the R here. So it's a pretty simple. When you do that, please remember that this table is going to be your expected, the proportion. So for example, the Asian, 12.7%. Now remember, 12.7%, you have to convert it to 0.127. 27.9. Now, obviously, that's going to be like a 0.279. So you have to make sure that you adjust this number. Again, this is going to be expected. Next one, this is the observed number. Okay, this is the observed number. So again, you do have to check our, those chapter 11 lecture. You're going to see the R tutorial. It's very simple. You just follow those instructions. Then you can do this test statistic and a p-value, draw the conclusion. Now, number 3 is like you just have to talk about, is this a kind of a good sample here? Now, please remember, this is not about whether we're going to reject the null hypothesis or we do not reject the null hypothesis. It has nothing to do with that. Go back to the chapter 1. We studied, many different sampling methods. Please look at this particular sample, the way that this, sampling is done, and you're going to determine whether this is a kind of an appropriate sampling here. And you have to explain. If you believe it is yes, then you have to explain why. And if you believe that no, also you have to explain why. And this is just the end of the project. So please make sure that your order solution, including the graph, is included here. So you have to submit this document and make sure that you go to this RStudio and use the this is save as. You are going to save this portion and you have to submit this R file. Okay, you cannot like copy and paste this into the another Word or PDF. You have to submit this one here. Okay, using starting with a new file, R script, and a save as, and you're gonna submit that file. Then I can see what you have. This one. Okay, so that's your project. And if you have like some questions, you can reach out to me, and then I will try to, respond to that, maybe in a timely manner. Okay, before the due date.